All right, here we've got your notes over target, or sorry, your homework over target 6. Got a lot of problems, so let's get to it. So starting with your first one, look for a greatest common factor. We don't have one, so we can go straight into our process of factoring. So we're going to look for two numbers that multiply to give you a times c, which is -4, and that add to give you b, which is 3. So those two numbers would be 4 and -1. So now we're going to rewrite our quadratic using those numbers. So n squared plus 4n minus 1n minus 4. And we're going to group. So that would be n and n plus 4. So now I'm looking for a common factor. So in the first set of parentheses, n is the common factor. In the second, -1 is the common factor. And I feel good about how I did this because these are the same. So that means n plus 4 is one of my factors, and -1 is another factor. So this would be the factored form. But I still have to solve, so I'm going to go ahead and set each of those factors equal to 0. And I'm going to solve each of these equations. So if I subtract 4, I get n equals -4 as one of my answers. And then here, if I add 1, I get n equals 1 as one of my answers. So we're looking for the factored form and then your zeros as well. So on number 2, same process. Look for your greatest common factor first. There isn't one. So we can go straight into what numbers multiply to give you a times c, which is 4, and add to give you b, which is -4. Those numbers would be -2 and -2. So rewriting your quadratic, x squared minus 2x minus 2x plus 4. Group. Look for your common factor. So your common factor here is x. And then the common factor here would be a -2 to give you that x minus 2. These are the same, so one of your factors is x minus 2. Your other factor is also x minus 2. That's okay for them to be the same. So that's your factored form. And then we're going to set each of your factors equal to 0 and solve. And notice that we're actually going to get the same thing in both equations. So you only need to write it once. So we can just say x equals 2. We don't need to write x equals 2 and x equals 2. If you want to, that's fine. Just not necessary. So I want to point out something before we continue. So on these two problems, the a value of the quadratic is 1. And so that's pretty significant because if you look at the two numbers that we chose, so we chose 4 and -1. Notice that those are the same numbers that are in your factors. Here, we chose -2 and -2. Those are the same numbers that are in your factors. And so that's actually a shortcut that you can definitely use, but it only works when a is 1. So I'm going to practice that so you guys can get used to that on your notes. So on number 3, a is 1, and so we can use the shortcut. First, we have to look for a common factor. There isn't one. And so we look for numbers that multiply to give you a times c, which is -40, and add to give you -3. So those numbers would be -8 and +5. They would meet both of those criteria. And so now, here's the shortcut. You can actually take those to your factors. It's going to be x minus 8 and x plus 5. That's your factored form. So you don't need to do the whole rewriting and grouping if a is 1. And then we can go ahead and set each of our factors equal to 0. And over here, if I add 8 to both sides, I get x equals 8. If I subtract 5 from both sides, I get x equals -5. Okay, so first thing I'm always going to question is whether I can use the shortcut or not. So on number 4, I'm going to look for a greatest common factor. There isn't one, so I'm going to go ahead and go into the factoring process. So numbers that multiply to give me a times c, which is negative 32, and add to give me the b value, which is negative 4. So I think negative 8 and 4 would work for both of those. Okay, so pause. Can we use the shortcut? Is a 1? Yes, it is. So go straight into your factored form. One of my numbers was negative 8. The other one was positive 4. Now to find your solutions, your zeros, we set each of the factors equal to 0. And I'm going to solve. So this would be x equals 8. And this would be x equals negative 4. Okay, so moving on to 5, I'm going to look for a greatest common factor. I don't have one, so I'm going to go into the factoring process. So numbers that multiply to give us a times c, which would be 14, and add to give us our middle number, which is 9. And those numbers would be 7 and 2. And then before I continue, I'm going to think about, can I use the shortcut? Is the a value 1? It sure is, so I can use the shortcut, go straight to the factors. I have positive 7 and positive 2 as my two values I picked before, so x plus 7 and x plus 2 are my factors. And then I'm going to find the solutions. So x plus 7 equals 0, and x plus 2 equals 0. And then I'm going to subtract, so x equals negative 7. And over here I'm going to subtract 2 on both sides to get x by itself, so x equals negative 2. Moving on to 6, first thing I'm going to do is look for a greatest common factor. 3, 16, and 5 are all not divisible by the same thing. So I'm going to go into the factoring process. So a times c would be 15, and then numbers that add to give you b, which is 16. So those numbers would be 15 and 1. And then I'm going to ask myself if I can use the shortcut, which I can't use the shortcut because the a value is 3 and not 1. So we have to do the big process. So we're going to rewrite our quadratic, 3x squared plus 15x plus 1x using those numbers we just chose. Then we're going to group. So in the first set of parentheses, the common factor is a 3x, which leaves me with x plus 5. There actually isn't a common factor in the second set, so we just say it's 1, because we can divide them both by 1, leaving me with x plus 5. These are the same. That means I did this correctly. So one of my factors is x plus 5. The other is 3x plus 1. So that's my factored form. So you can tell that if you can use the shortcut, it's definitely beneficial. It makes the process go by quicker. And then I have to find the zeros, so I'm going to set each of those equal to 0. So if I subtract 5, I get x equals negative 5. If I subtract 1, I get 3x equals negative 1. I still have to divide by 3, so I get x equals negative 1/3. All right, moving on to 7. I'm noticing on 7, just right off the bat, I'm not going to be able to use the shortcut just because a is not 1. So then I'm going to look for a common factor, and I don't have one. 5, 22, and 8 are all not divisible by the same thing. So going into the factoring process, we're going to do numbers that multiply to a times c, which would be 40, and add to your middle number, add to your b value, which is negative 22. So numbers that multiply to 40 but add to negative 22 would be negative 2 and negative 20. So now, since I can't use the shortcut, I have to rewrite my quadratic. So 5n squared minus 2n minus 20n plus 8 equals 0. And we're going to group. So that would be an n. All I can take out from both those is an n, leaving me with 5n minus 2. In the second set of parentheses, I can divide both those by a negative 4, leaving me with 5n minus 2. So since 5n minus 2 is the one that's repeated, that's one of our factors. The other one comes from your 2 GCFs, which is n minus 4. So that's your factored form. And then with your zeros, we're going to set 5n minus 2 equal to 0, and also n minus 4 equal to 0. So in this first one, if I add 2 to both sides, I get 5n equals 2, and if I divide by 5, I get n equals 2 fifths. On the second one, if I add 4 to both sides, I get n equals 4. All right, cruising right along. Number 8, we have another quadratic without a common factor. And so we also can't use the shortcut because a is not 1. So we're going to go straight into our factoring process. So numbers that multiply to a times c, which would give me 20, and add to your middle term, which is 12. So numbers that multiply to 20 and add to 12, we would have 2 and 10. Sometimes it takes me a minute to figure out the numbers too. So rewriting my quadratic, we can't use the shortcut. Bummer. So grouping. Now common factors. So the common factors in this first set is 5b, leaving me with b plus 2. Common factor in the second set is 2, leaving me with b plus 2. So the factors would be b plus 2 and 5b plus 2. And then we're going to go to the zeros. So b plus 2 equals 0, and 5b plus 2 equals 0. So if I subtract 2 on both sides here, I get b equals negative 2. If I subtract 2, I get 5b equals negative 2, but I still have to divide by 5. So b equals negative 2 fifths. All right, moving on to number 9. So on number 9, again, we do not have a greatest common factor. So going straight to the factoring process. Can't use the shortcut either. So a times c would be 56, and then add to give us negative 57. So numbers that multiply to 56 add to negative 57, negative 1, and negative 56. And then we are going to rewrite our quadratic. So 7b squared grouping. Look for the common factor. Then your factored form. And then your zeros. Okay, so I'm taking away some of the instruction just because it's the same every single time. It's the same steps that were written on your notes. So Look for greatest common factor, number 10. There isn't one, so go into factoring. A times C is negative 42. B is 1. So the numbers that would meet this criteria are 7 and negative 6. So rewrite your quadratic since you can't use your shortcut. Group. Common factor. First common factor would be an n. Second one would be a negative 1. Then write your factored form. And find your zeros. All right, flip it over. So if you notice the directions here, it says make sure you look for your greatest common factor first. So that's an indication that maybe these problems do have a common factor. So looking at this first one, all of those numbers are divisible by 7. So I'm going to go ahead and start by dividing all of them by 7. And remember, when you decide there's a GCF, you do need to put that number on the outside, so 7. So the great thing about this one is that now that we took out the common factor, your A value is actually 1. So you can go back to using that shortcut. So I'll remind you of it. So A times C, and use your new A and C, so that'd be 24. Add to your middle number, which is now 10. So your numbers are 6 and 4. So the shortcut, you put your common factor out in front first. Don't want to lose that. And then you just use your numbers. So we had positive 6, so x plus 6 and x plus 4. And again, this only works because our new A value was 1. So once we took out that common factor, the A value is 1. So then if we set each of our factors equal to 0 and solve, and if you are, if you like fast forwarded to this part and you're like, what are you talking about with the shortcut? Go back and look at numbers like 3 and 4. Right before I started 3 and 4, I talked about the shortcut. All right, so then same thing on 12, look for a common factor. So they're all divisible by 4. So I'm going to go ahead and put a 4 out in front and divide them all by 4. And now the new A value is 1, so we're going to use the shortcut again. So A times C would be 6. Make sure you use your new A, B, and C. So these numbers would be negative 1 and negative 6. We're using the shortcut but not forgetting the GCF. So the shortcut says we go straight to the factors with those two numbers we chose. This is the factored form. And then we can find the zeros by setting those each equal to 0 and solving. All right, moving on to number 13. Let's look for a common factor. I do believe all of those are divisible by 4. So I'm going to put a 4 on the outside. X squared minus, that would be 5x. Oops. Minus 14. So let's look for numbers. Make sure you use the new A, B, and C. So numbers that multiply to negative 14, add to negative 5. Those numbers would be negative 7 and 2. So we can use the shortcut. A value is 1. So, don't lose your 4 on the outside. There's your factored form. And then you can set each of your factors equal to 0 and solve. So this would be x equals 7. this would be x equals, if I subtract 2, that would be negative 2. Looking at number 14. So on 14, those numbers are all divisible by 3. So taking out the GCF. So numbers that multiply to negative 16 and add to negative 6, those numbers would be negative 8 and 2. Can we use the shortcut? Is our a value 1? It sure is. So let's go ahead and write our factors. I just realized I've been changing the variable throughout these problems, which is okay. Don't forget your common factor. If you want to change it to x, you can do that. I think that's what I've been doing. And then we set each of our factors equal to 0 and solve. All right, looking at number 15. Look for your common factor first. All of these numbers are divisible by 2, so I'm going to do that. And then numbers that multiply to negative 7 and add to 6. So 7 and negative 1. The a value is 1, so I can go straight to the factors. So I have b plus 7 and b minus 1. And then set each of your factors equal to 0. That's my factored form. So b equals negative 7 and b equals 1. All right, so moving on to number 16, again, we're looking for a common factor, and I think all of those numbers are divisible by 4. I don't think anything bigger. So remember, you're always looking for the greatest common factor. So as I'm writing this, I'm recognizing that a value is no longer 1. So we are going to have to work around that, and we're going to have to do the long method. So we want numbers that multiply to negative 14 and add to negative 5. Those numbers would be negative 7 and 2. So now we're going to rewrite our quadratic. Remember, we can't use the shortcut. A is not 1. So that would be 7n squared minus 7n plus 2n minus 2. Group. All right, we're going to look for a greatest common factor in each of these. So 7n is the common factor in the first set of parentheses. 2 is the common factor in the second set of parentheses. So now we can write our factored form. So 4 out in front, and minus 1 is the same. GCFs were 7n and positive 2. That's your factored form. Finding your zeros, set each of your factors equal to 0 and solve. And working on to number 17. So again, look for your greatest common factor. And I'm not sure, I think it's just going to be, if there is one, it's just 3. 123. Yeah, I think it's just 3. So these are going to be some pretty big numbers. I just forgot what that was. 29. So then numbers that multiply to a times c, so this will be a pretty big number, negative 210, and add to your middle number, negative 29. So, that's not going to work. I'm just working on some different numbers. Okay, so I think negative 35 and 6 would work. So now we're going to rewrite our quadratic with those numbers. And then group. And then look for your common factors in each of those groups. And then write your final factored form. And now we're going to find our zeros. So set each of them equal to 0. So this would be b equals 7. And here if I subtract 6, and then divide by 5. All right, looking for our greatest common factor again. I actually think I can divide all these by 6. So that would be 5x squared minus 28x plus 15. So then numbers that multiply to 75 and add to negative 28, negative 3, and negative 25 would be your numbers. So then again, so on these, just notice our a value has not been 1, so we have to take the long method. So I'm rewriting. And then I'm going to group and look for the common factor. Now I'm going to set each of my factors equal to 0. And then moving on to number 19. So look for a greatest common factor. So they're all divisible by 3. Still can't use the shortcut. A is still not 1. Oops, equal. So our numbers here would be 12 and 4. So now we're going to rewrite our quadratic with our new numbers. Group. And then take out your greatest common factor. And then write your factored form. And then find your zeros. All right, last problem. All of those numbers look like they would be divisible by 5, so we're going to go with 5 as the GCF. So then we're going to do A times C. So that would be 105. And then numbers that add to 22. Multiply to 105. And add to 22. So 15 and 7. So then we're going to rewrite our quadratic. And group common factor. And then factored form. And find your zeros. All right, your homework is finished.